Okay, so 11.2 is proving figures are similar, not congruent, just similar, using transformations. A similarity transformation is a transformation in which an image has the same shape as its preimage. Similarity transformations include translations, reflections, rotations, and dilations. Two plane figures are similar if and only if one figure can be mapped to the other one through one or more similarity transformations. Are these figures similar? If so, what transformations are used? Now these are the same size, so this is only a rotation, 180-degree rotation. Just like this is just a reflection. On this page, if we check out 1, 2, 1, 2, 3, and this one is 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. And then this side is 1, 2, 3, 4, 5, 6. And this side is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these are two similar figures. They have the same shape. And a dilation is used with a scale factor of 2. Now you can represent dilations using the coordinate notation xy goes to kx, ky. Some number times x and the same number times y. Now if that number is between 0 and 1, the dilation is a reduction. It gets smaller. And if that number is greater than 1, it's an enlargement. So let's look at how dilations affect figures. So if we look at this, let's check two sides here. So 1, 2, 3, 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So this figure, 2, that is a 2, and 1, 2, 1. So this is a dilation. Yes, these two figures are similar because of a dilation with a scale factor of 3. Now if we check two sides over here, I've got 2 and then 1, 2, 3, 4. Here I got 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. All right, these are not similar because they don't have the same scale factor. These two is a multiple of 2. I would need the same thing here. All right, so now determine if the figure using similar transformations. So here, 1, 2, 3, 4, 1, 2, 3, and then I have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. So dilation, they are similar because of a dilation with a scale factor of HG. I think that gets smaller, so 1/2. Oh, wait, right here it says, yeah, L. Well, it doesn't really tell you which one comes first. But if we're going with this one came first, then it would be a scale factor of 2. Okay, I can already tell these two aren't similar. Here, this is 1, 1, 2, and then 1, 2, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2. So, scale factor of 1/2, and they are similar. Then these next ones, I've got the directions on one page and the shapes on another. Find the sequence of similarity transformations that maps the first figure to the second. So we're going to find the sequence. We're going to have a couple of different transformations that we're going to use. Alright, so the first thing I like to do is look here and put my letters A, B, D, C. I don't know why they didn't go in alphabetic order. They should. And I'm going to write down my points. A, B, D, C. A is at 1, 6. B is at 5, 6. D is at 2, 2. And C is at -2, 2. Alright, so it's easy to tell the scale factor. 1, 2, 3, 4. 1, 2.5. Well, I thought it was easy. No, it is 4, yeah. And then, is that 2.5? I can't see. Oh, it is just 2. The dang half marks threw me off for a second. But it is just 2. So good. So it's a scale factor of 1/2. So my next points would be at 0.5, 3. B prime would be at 2.5, 3. D prime would be at 1, 1. And C prime would be at -2, 1. So let's plot these. 0.5, 1, 2, 3. I'm going to put these in purple. 2.5, 3. D's at 1, 1. And C's at -1, 1. Alright, now I see that my A, let's just look at A. He needs to come down 1, 2, 3, and over 1, 2. So that's a first XY goes to 1/2 X, 1/2 Y. It got smaller by 1/2. Then goes to X plus 2. Oops. Y minus 3. Let me put that in pink. Down 3 over 1, 2. And that's how I write the transformations. Okay? So then let's look here. JKL to P. Oh, there's P. J, K goes to Q. L goes to R. Alright, so, like I said before, orientation first. So, well, I like them the same size also because sometimes they move when you make them bigger. So, we got 1, 2, 3 to 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's the scale factor of 3. And then let's check this out. J is at 0, 1. K is at 1, 2. And L is at 3, 1. Now, I'll put in purple. If I multiply by 3, I'm going to get these. 3 times 3. All right. So I got 0, 3. There's my J. K is at 3, 6. And L is at 9, 3. Okay, so I need to rotate and then flip. So if I rotate 90 degrees, this is going to be really hard to show you. But if I rotate J double prime 90 degrees counter, clockwise, and this one is really, really, I'm going to just stop there. I'm going to show this one in class because they did not make this easy for me to show you. Let's jump to the next one. The next one is really easy to talk about in this video, and I'm sorry, I just usually do this in class. So let's go here to number 8. And PQRS to TUV. So P is going to go here, Q here, R and S. And it's going to get smaller, isn't it? All right, so it looks like it's getting smaller by 1, 2, 3, a third. So XY goes to 1/3 X, 1/3 Y. And I can see that because this one is 3 and this is 1. All right. So, and a reflection. So if I reflect that first, and reflecting it first might be easier. So if I put P here, 1, 2, 3, 1, 2, 1, 2, 3. P goes here. S goes here. Q goes here, and R goes out here. Okay, now do you see it's oriented right? The R is up in the left corner, the Q's up in the right corner. Now let's just get it smaller. And I'm going to write and a reflection. Which would be opposite X, Y. So P is at, let's just look at 1 point, -3, 3. If I divide it by 3, I get -1, 1. And that's exactly where P should be. So those are the only two things I have to do for this shape. Reflect it and reduce it to a dilation smaller. And see, that's the kind of problem I want you to be able to do, not this problem. There's way too much going on there. So just reflect it and then do your reduction, okay? Isn't it? Yeah, and here, same thing. PQRS. Oh wait, that's the same one. On there twice. What do you know? Okay. Let's look at this one and make sure. I think this, I want to make sure it wasn't rotating it around a point. I don't think it is. So JKLMN starts off. So we know it's going to be a reduction, right? And at 1, 2, 3, 4, J is going to V, K, L, M, N. So JN is 4 originally, and now it's 2. So we know we need a scale factor of 1/2. Now, do you see I have to flip it? Okay, so let's just reflect it. I did not mean to erase the letters. V is J. J, K, L, M, N. Let's see, let's just reflect it. 1, 2, 3, 4, 5, 6. 1, 2, 3. If we reflect it over this line, and I'll put that in pink. 1, 2, 3. So 1, 2, 3. That puts J up here and L down here. N goes here. M will go here. N goes 1, 2, 3. Oh, I already did N. K will be here. Okay, so now I have it same. And then because there is no XY axis, it's really hard to tell. But the 1/2, we will also need a translation after it and to move it. But I'm not going to expect you to do one without the X and Y axes. So don't worry about that. Proving all circles are similar. We're not going to prove it. Just know it. All circles are similar. And that is it. Let me make sure none of these problems are with you to help out maybe a little bit. This one is a straight dilation. You're not going to need to do anything to it but a dilation. Just figure out what that dilation is. Okay. This one is not similar. This is a dilation. Just figure out what the scale factor is. Crazy. That's just a flip. And let me run through them real fast. This one, they are not similar. Oh, this one, let's see. PQA BC goes to PQR. PQR. So if I rotate that, around. Okay, this is a reflection. No. You need a rotation. 1, 6, 1, 6, 1, 6. And then you're going to need a reflection, so don't worry about this one. There's a couple in there. This is just a reflection and a dilation. Maybe a translation, but I don't think so. 1, 2, 1, 2, 3, 4 is a dilation and a reflection. So just write it out. I think this is going to be a dilation and a translation. A B is J. Okay. No, there's a reflection in there. And then maybe a translation. But that would be okay. That's just a flip. Alright, we don't have to do that one. A, B, C to J. D maps to M. Okay, so this is dilation and a reflection. And that should be all. Maybe a translation. Okay? But that'll help your homework go a little easier. And I'm sorry I messed up that video. I will see you guys. Bye.